When you're making a bracket or doing a repair of this size, you want to bring the temperature up slowly. The only mistake you can make with this rod is to overheat. If you heat until this flux turns black instead of root beer brown, the metal's too hot. If the metal's too hot, the rod will tend to fluff up, get air under it. You want to cool it down, clean up, and start over. It's very simple. It's just a matter of knowing that. Now, first the flux begins to bubble, and then you'll see that root beer color appearing. The slower you bring it up to temperature, the nicer flow you get. Now, you see that root beer color? When you get to that point, just let your rod lay against the metal and get the rod started by putting the heat a little bit above it, a little bit below it, and just let it go. Once the rod starts flowing, just bring in a little heat at a time to keep it going. Put your heat on the back just a little bit, and that will pull it through. Nice penetration. Here's the finished piece. Look how nice that bead looks. All we did is wire brush the flux off. No machining was necessary. And you see where we made the repair, as if it were a hole in a line or a tank or a door panel. You can't get that off with a hammer and a chisel. Okay? Look at the back. 100% penetration. This isn't very scientific, but it should give you the idea of just how strong superalloy number 1 is. There we go. Smash. Not done yet. One or two more good hits ought to do it without knocking that over. Is that strength? And remember, this is brass to aluminum. Now again, this rod will work on virtually every metal that's out there. If it's going to do brass to aluminum and give you this kind of strength, just brass to brass, just steel to steel, just galvanized, just copper, at least this strong. The only exceptions for this rod are magnesium and cast iron. Other than that, you can do any metal by itself or any metal to any other metal.